Good morning, students. This is the fourth video of carbon and its compound. Let us revise some few key points of this chapter. Carbon's ability to form a vast and diverse range of compounds stems from its unique atomic properties. This has led to the entire field of organic chemistry, which studies carbon-based compounds that forms the basis of all life on Earth. Versatile nature of carbon. Tetravalency. A carbon atom has 4 valence electrons, allowing it to form 4 stable covalent bonds with other atoms, including other carbon atoms, hydrogen, oxygen, nitrogen, and halogens. Catenation. Carbon has the unique ability to form long chain, branch chains, and a ring by bonding with other carbon atoms. It can form single, double, or triple bonds with itself, creating an immense variety of complex and stable molecules. Allotropy. Carbon exists in various forms or allotropes with different physical properties but the same chemical composition. Key examples include diamond, graphite, and fullerene. A diamond is a hard, transparent, three-dimensional structure that is a poor conductor of electricity. Graphite, a soft, black, layered structure where carbon atoms are arranged in hexagonal arrays. It is a good conductor of electricity. Fullerenes. Spherical molecules such as C60 with atoms arranged in pentagons and hexagons often resemble a soccer ball. Types of carbon compounds. Carbon compounds are categorized based on their bonding and structure. First of all, hydrocarbons. The simplest organic compounds made up of only hydrogen and carbon atoms. They are further divided into saturated hydrocarbons. Alkanes. These contains only carbon-carbon single bonds. They are generally unreactive. Unsaturated hydrocarbons, alkenes and alkynes. This contains one or more double alkenes or triple alkynes bonds between carbon atoms. They are more reactive than alkanes. Functional groups. Specific arrangements of atoms that are attached to carbon chain and are responsible for a compound characteristics chemical properties. Example includes halides, alcohols, aldehydes, carboxylic acids, and ketones. Homologous series. A family of organic compounds that have same functional group and similar chemical properties. Adjacent members of the series differ by CH2 group isomers. Compounds that have the same molecular formula but different arrangement of atoms. Now we can see further some important hydrocarbons. In this chapter we will study some important hydrocarbons. The first one is ethanol. It ends with "-ol". It is an alcohol. It is also known as ethyl alcohol. It is an alcohol of chemical formula C2H5OH. The properties: a clear colorless liquid at room temperature, has a characteristic slightly pleasant odor and a burning taste, highly flammable and produces heat, carbon dioxide and water when burned. Highly soluble in water and other organic solvents. A volatile organic compound, meaning it easily evaporates. Uses of alcohol. It also used in beer, wine and spirits. Also used in food flavorings like vanilla extract. An additive to gasoline known as gasohol to boost octanes and powers. Students, nowadays the very hot topic general knowledge is E20 petroleum. So nowadays our government mixing ethanol with petrol up to 20%. So what we are getting in the petrol pump is not 100% petrol. It is a petrol mixed with ethanol. So 20% ethanol and 80% petrol. It is a versatile solvent for perfumes, paints, oils, fats, and various industrial chemicals. It is effective at killing bacteria, fungi, and viruses, making it a common ingredient in hand sanitizers, medical wipes, and antiseptics. It is found in various pharmaceutical preparations like tonics, rubbing compounds, lotions, and cosmetics. It is used as a reagent and a polar solvent in the creation of other organic chemical compounds. It is present in cleaning products, polishes, and hairspray. Chemical properties of ethanol. Combustion. Ethanol is highly flammable and burns with smokeless, clean blue flame. This property makes it is a useful fuel. When it burns in the presence of sufficient oxygen, it produces carbon dioxide water. So you can represent this reaction as a formula equation C2H5OH plus 3O2. It gives 2CO2 plus 3H2O. The next reaction, chemical reaction, is oxidation reaction. Ethanol oxidizes into various agents. A strong oxidizing agent like acidified potassium dichromate, that is K2Cr2O7, or alkaline potassium permanganate, KMnO4. So it oxidizes into ethanoic acid. Then other reaction is dehydration reaction. Heating ethanol with a strong acid like concentrated sulfuric acid removes a water molecule from the compound. The outcomes of the dehydration depend on the reaction condition. Now, reaction with ethanol reacts with sodium. Ethanol reacts with sodium to form sodium ethanoate, sodium ethoxide. So you can see the equation 2C2H5OH plus 2Na, it gives 2C2H5ONa, that is sodium ethoxide plus H2. So this is a very important equation and reaction. Now it's also represented here in the slide as the dehydration of ethanol. In the presence of H2SO4, ethanol dehydrated into ethene. The next compound is ethanoic acid. The formula is CH3COOH. The other name of ethanoic acid, that is a common name, is acetic acid. It is a colorless liquid with a sour taste and pungent vinegar-like smell. It is soluble in water and is a weak acid that turns blue litmus paper red. 5% of concentrated ethanoic acid, it is mixed with water. That is a 5% of ethanoic acid is a vinegar, what we are using in the cooking and many reagents. It undergoes key chemical reactions, that is esterification and saponification and so on. And what is esterification? Ethanoic acid reacts with ethanol to form ester, ethyl ethanoate, in the presence of concentrated H2SO4. You can see the equation here. Ethanol, ethanoic acid, you know the formula of ethanoic acid, that is CH3COOH, and ethanol C2H5OH. You remove water. So what will happen? Ethyl ethanoate will form. That is an ester, CH3COOC2H5. So this reaction is known as esterification. Esters are characterized by their sweet, pleasant odor and are used in flavoring fragrances and solvents. The next reaction is saponification. So it is a soap making process. When ester reacts with sodium hydroxide solution, sodium salt of carboxylic acid and the parent alcohol are formed. This reaction is called as saponification. So this reaction I already told you, it is used for making soaps. And here the esters, usually fats or oils, usually used for making soaps, and sodium hydroxide or potassium hydroxide, the base, the solution will be used for saponification. So here the reaction involved CS3 COO C2H5, that is ester ethyl ethanoate, plus NaOH sodium hydroxide. You can instead of sodium hydroxide you can use potassium hydroxide also. The nature of soap will change here, and the salt will form, and that is a soap. Then alcohol will form C2H5OH, and ethanoic acid reacts with bases to form salt and water like other acids. It's a neutralization reaction. Any acid reacts with base to form salt and water. The same way it also behave like other acids. So acid react with sodium carbonate to form salt, water and carbon dioxide. So the same reaction you can mention here, and ethanoic acid react with sodium bicarbonate to form salt, water and carbon dioxide. So these are the reactions you can see. It's very important reactions. Students, you have to learn these reactions, because the equations, suppose reactions means you have to learn the equations. Now next topic is soaps and detergents. Soaps are sodium or potassium salts or fatty acids. I already told you, if you use sodium hydroxide, the salt will form sodium salt. So the soap will be sodium soap. If you use potassium hydroxide, you can get the potassium salt of fatty acid, that is a soap, okay, derived from natural oil and fats, and are biodegradable but form scum in hot water. So soaps are used to remove dirt and grease from our body as well as from clothes. So suppose the water is very hot, that means a lot of salt ions will be there, so it will form scum. So you can see some scum, that means the white like structure. So you can see, suppose you are using soap in the bathroom. So to avoid that, to increase the cleansing action, so the scientists invented detergents. Detergents are salt of long chain of sulfonic acids or alkyl sulfates, primarily made from petroleum, and are non-biodegradable. So there is a difference. So soaps are made from natural oil, detergents are made from petroleum products. Soaps are biodegradable and detergents are non-biodegradable. So which will cause pollution. So suppose you are using soap, it is not as much harmful as you can use detergents. So detergents remain effective in hard water and not form scum. Both work by forming micelles to trap dirt, but detergents are generally more powerful cleaners and are preferred for use with hard water. Now I will explain the cleansing action of the soap. So soaps and detergents can clean, because if you see the molecules of soap in the slide, there are two parts in the molecule of soap. One is hydrophobic, that is water hating. The other one is hydrophilic, that is water loving. So one end of the soap molecule is water phobic, that is water hating, but it will attach with a grease. The other ending is water hydrophilic, that is water loving, that is away from the grease, that dissolve in water. So when agitated in water, soaps or detergents, this molecule form micelles with hydrophobic tails surrounding the dirt or oil particles, and the hydrophilic heads facing outward into the water. So this arrangement is used to, so suppose you can see this slide, the cleansing action you can easily understand, and how the molecules attach with the dirt and all. And the next one is differentiate between soaps and detergents. It's a very important question. So first of all, you have to understand the question, then you have to topic, then you have to learn also. Soaps are sodium salts of fatty acids, but detergents are sodium salts of sulfonic acids. Soaps clean well in soft water but do not clean well in hard water. But detergent clean well in both hard and soft water. Soaps do not clean as well as detergents. Detergents clean better than soaps. Soaps are biodegradable and do not cause pollution. And some detergents are non-biodegradable and cause pollution. So students, the chapter is over. So there are 4 videos for this chapter. So you do one thing, again you start from you watching all these videos of these chapters. It starts from video number 4, 5, 6, 7. There are 4 videos in this chapter. You see the videos again and again to understand the core concept of the chapter. So I already told you, after that you have to read the book. That is very important. That is a habit to learning process. You have to read the book again and you have to try to answer the question answers from the books. So that's the way you can understand the chapter and can able to solve many questions. Okay, so thank you for watching my videos and don't forget to subscribe my channel. So I will publish more videos from the chapter Light. Thank you and have a nice day.